All right, welcome back. Today we're going to talk about dilution problems. Kind of save the easiest for last. Hopefully they're easy for you. Dilution is a concept that should be familiar. Anytime we dilute something, it's made less concentrated. And it's made less concentrated because we are adding more solvent. In a chemistry classroom, typically we are adding more solvent to what is called a stock solution. So real quick, let me just make sure you understand. A stock solution, if we go into the stock room, is something that is a concentrated solution. So when we do labs in chemistry class, I don't have in the back room a 1 molar solution, a 2 molar solution, a 3 molar, 4 molar, 5 molar, etc. For like hydrochloric acid, I might have a 12 molar solution, I have a 6 molar solution, I might have a 1 molar solution. And then for whatever labs we need the molarity of, I just dilute them from those stock solutions. And so when I am diluting them, this decreases the molarity. When I add more solvent. All right, so the unit for volume in these is independent from molarity in our equation. So it can be left in milliliters or any unit as long as your volumes are consistent. So if V1 in my equation is in milliliters and V2 is in milliliters, then that's fine. But if V1 is in milliliters, V2 cannot be in liters. You'll also see this equation sometimes referred to as MIVI equals MFVF. And the I's and the F's are used for initial and final. That's more of when you take physics, you have an initial set of conditions and a final set of conditions. I like to use 1 and 2. I think the 1 and the 2 are more common, but you might see the I's and the F's. They mean the same thing. One thing I want you to be careful of, just cautious, and it's just paying attention to details, is when you are looking at your V2s, reading comprehension, very important. That V2 may be given to you directly. Like they may say the volume is changed to this, or you may need to figure it out. So may need to be found by adding V1 to the given volume. So for example, if they say you started off with 50 milliliters and then you added 60 milliliters. If you start off with a V1 of 50 milliliters and then you add 60 milliliters, V2 is not 60 milliliters. V2 is going to be 110 milliliters because you added 60 milliliters. So just make sure you're careful with that. All right, so let's look at this. Calculations. A stock solution of sodium sulfate has a concentration of 1 molarity and a volume of 50 milliliters. So we have an M1 and we have a V1. What volume, so we're looking for a V2 of 0.25 molar, so we have a M2, excuse me, could be made from the stock solution. So I'm going to make a table, M1, V1, M2, V2. V1, 50.0 milliliters. M2, 0.25. Again, it's getting less concentrated because we're diluting it, and we want to know what what volume. And again, milliliters is fine. My equation M1 V1 equals M2 V2. We're going to plug and chug. M1, 1.00 molar. V1, 50.0 milliliters equals M2, 0.25 molar. V2 question mark. We multiply 1 times 50, divide by 0.25, and we get a V2 equal to 200, and sig fig wise, 0.25 only has 2, so how do we make 200 have 2 sig figs? We got to put it into scientific notation, so 2.0 times 10 to the second milliliters is our V2. Again, 1, 2. All right, our second problem, a sample of, here's our V1, concentrated sulfuric acid is used to make 250, here's V2 of 0.50 molar, that's our second V2. What was, oh, that should be what was the initial concentration, so that was M1, M1. All right, so we have M1, V1, M2, V2. M1, we said, is what we're looking for. V1 is 7.0 milliliters. M2 is 0.50. V2 is 250 terminal decimal milliliters. Use our equation, M1 V1 equals M2 V2. M1 is what we're looking for. V1 is 7.0 milliliters. M2, 0.50 molar. V2, 250 milliliters. Rearrange, solve for, we multiply 0.50 times 250, divide it by the 7.0 with 2 sig figs, we get 18 molar. One more quick problem just to do that situation where we have a possibility where V1 or V2 has to be found. Let's do this where we have 1.00 liters of a 1.35 molar solution is diluted by adding 450 milliliters of water. Calculate the final molarity of the solution. So we have M1, V1, M2, V2. Let me switch colors then. So M1 is the 1.35 molar. V1 is the 1.00 liters. But we're adding 450 milliliters. We have 1.00 liters plus 450 milliliters. So the problem with that is we can't just add those two. One is in liters, one is in milliliters. So we have to move our decimal and make this 1.00 liters plus 0.45 liters. And that gives us a new volume of 1.45 liters. Hope you followed that. So now we have M1V1 equals M2V2. M1 is 1.35 molar, V1 1.00 liters. M2 is what we're looking for. V2 is 1.45 liters. Solving for M2, we take 1.35 times 1, divide it by the 1.45 liters, and we get a new molarity of 0.931 molar. All right. So now your homework will be to practice this.